Let's get started on Unit Standard 25704. This is the round to square offset transition. We're going to develop the pattern out for this shape object here. Now don't panic about all this maths that's all over my page. That was just for me to sort out the size to put on my piece of paper and to work out where the mean is. That's the middle of the thickness of the material that we're doing. Now, depending on what the assessor is looking for, he may want you to make allowances for the perimeter. So here's a perimeter, it's 320. Now the maths is quite simple for working this out. So there's 4 of these perimeters. In my case, it's a square base around here, and it's 320 on each of the 4 sides. So to find the mean perimeter, we simply have this formula here. Mean perimeter equals 4 times the base, in this case 320, minus 4 times half the material thickness. Now I'm going to make this out of 6mm. So 4 times, well, half of 6 is 3, so 4 times that is 12. So it's simply 4 times the base, 4 times 320 equals 1280mm minus 12. So that is the size of the piece of metal that I'm going to have to make. So what we have to do is adjust these. So to take 3mm off of each side makes each side 317. Now we have to do it because we measure on the outside, but we actually put our dimensions on the inside. So that's why we have to make allowances for the material thickness. I have to scale it all down because obviously 320 is too large, or in this case 317 is too large to fit on my piece of paper. Whenever you do a drawing, always dimension it as if it's full size. Do not put the dimensions on here in the scaled measurements. That just causes a lot of confusion. Now our finished drawing with the pattern laid out should look like this. Now I have to emphasize at this point, accuracy is very, very important. So take your time and be very accurate. We can check our accuracy by making sure that the start and finish is exactly 90 degrees in this corner. And the finish should also be 90 degrees in the corner. And that way we can be sure of getting our pattern exactly right. We have to work out where the seam goes. Well, again, I'm a welder and we want to spend as little time as possible as welding. So normally we put the weld or the joining method on the shortest seam. This could be riveted together. It could have a sheet metal seam if it was thinner material. So what we have to do is work out where the seam is, and we work from the seam on our drawing out. Now this is drawn in triangulation, hence all the triangles here. I'm going to show you how to do that as we get into it. So the first thing we have to do is we have to draw the plan and we have to draw the elevation on our piece of paper. Let's get into that. Right, I mentioned accuracy. Accuracy is very, very important in this. I'll say it again, accuracy. Most of the faults from doing triangulation like we're going to do comes from inaccurate laying out and use of compasses and that. Let's draw the plan and elevation. Start with a baseline. And we'll take our lines up. .25 is about that. And I can take that line all the way up to the top. Now my construction lines I'm drawing quite dark so that you can see them. You'll draw yours much lighter. So this is the elevation we're drawing. So this view here, we have to come in 50mm and we have to go up vertical 220. With scaling, 220 becomes 55, so 220 divided by 4 becomes 55. Now your one will look slightly different to mine because I've changed my measurements. Now we have to divide our circle into 12 equal parts, and that's best done with the 30-60 degree set square, working from the center of our circle. Now those points are very important. Oops, let's do them all. Those points are very important. We can draw in our outlines. Now we've identified these points here. We need to join those to the corners. So do this for each corner. Right, now that we have those done, let's next identify where the seam is. So we're going to have the seam on the shortest side. So we'll put that in there. We'll even label it seam so we know what we're talking about. Righto, now let's label everything so it helps clarify what I'm doing. Corner A, corner B, corner C, corner D, and of course the seam, and that'll be square. Let's start the seam off at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and that 0 is also 12. We'll now transfer all of that information down to this lower drawing, and I have to bring those points down from the top view. So the circle, take this point of the circle and bring it down to the top edge. Take this point, number 11, which is also number 1, and bring it down to the top. Take this point, so number 9 is already there, number 8, take that point, bring it down, and number 7. Number 6 is the outside. So let's join all of those up. And we will label everything. So that is 6, and that is 12 and 0, and then we have 1 and 11, and we have 10 and 2, and we have 3 and 9, 4 and 8, 5 and 7, and down here we have B and C, and down here we have A and D. Now let's pay attention to these dotted lines here. There is nothing on here that is actually a true length line, because these are sloping inwards. These are sloping inwards, but they're also sloping away from us. So not only are they sloping in, but they're sloping away. So none of these are true lengths. So now we have to find what the actual length of this line is. So 9 to D, 9 to D, there's two different lengths here, and neither of them are true lengths. As I said, the only true length line is the seam line that runs down here. So this is where triangulation comes in. So what we have to do is use the elevation height. So let's label the bits we're looking at. Elevation, and the plan. These are the views that we need. So we take the elevation height, put the plan length in at right angles, and the resulting hypotenuse is the true length line. Okay, so we take the elevation height, the plan length, and the resulting hypotenuse is the true length. Now I'll use an assortment of colours here so that we can follow along quite easily. First, we need to put in a baseline. So let's do that. So this is the base of the elevation, and we need the height of the elevation. So the formula we're looking for is the elevation height and the plan length, and the resulting hypotenuse is the true length. Righto, I've written that in. Elevation height and the plan length, the hypotenuse equals the true length. So let's have a look at what that looks like in practice. So using some quality sharp compasses, we have already determined the elevation height, and now we need the plan length. So I put A0 or 0A and put it from the base point here. I can label that A0. Now there will be a lot of these. I'll change the color, so I'll do all of A in purple. So that's A0. Look at A1. Now some of these will be very, very close together. A1. A1. Let's do A2. There's a slight change. Mark that. So we have the elevation height. This is the plan length we're putting in. It's very close. Now, don't think that because it's close, near enough is good enough. You must get these accurate, or else your pattern will look all wonky. And A3. So here we have A2, and here we have A3. So because this circle is sharing this center line, it's obviously not in center this way, but because it's in center this way, we only have to do two of these. We only have to do A and B. If this circle was in a corner somewhere, we would have to do true lengths for all four. So this satisfies A and D. So let's add these down here. So A0 would equal D 0 or 12. A1 equals D11. D11. A2 equals D10. And A3 equals D9. So they're the same true lengths. So let's get on to the next one. For clarity, normally I stick these all on the same point, but for clarity I'll draw another vertical height. And we will do the same thing for B and C. So let's take B3, put B3 along that base. Let's change the color. We'll do this in green. So we've got the elevation height and we've got the plan length. Plan length, elevation height. And that is B3. This is B4. This is B5. Make sure we're attaching to this point exactly each time. B5, and the last one will be B6. And that is B6. Now, same as with A and D are the same, B and C are the same. So B6 is the same as C6. C7 is the same as B5. C8 is the same as B4. And C9 is the same as B3. And we're ready now to start doing our development of the pattern. Our pattern development starts at the seam and it starts with a right angle. Let's draw a right angle in here. Pretty close to this. I'm not quite sure where this is going to end up. We'll put a right angle in here. Now, as I said, the only true length that comes with this drawing is this, and this is the seam. So we can put that measurement in. Let's draw that in dark. So this is the seam. So what we want to do now is identify this line here, and we know that that is a right angle. So we know the length of that. We can take it off the drawing, or we can measure it because we've worked it out mathematically. We'll take it off the drawing, and I'll put that there. So that is a right angled corner. I can draw that in. And put the symbol in for a right angle. Now we're at A, and this is point 0, A0. So we can draw a dotted line A0, and that is in purple. So let's do that, and we'll be able to see the magic of what we've done. So that's A0, a true length line. Now we've worked out down here that that is A0, so let's double check our construction of true length lines, and that there will be exactly the same length. So that is A0. Let's put the A in. A0. So that's the first part. So we have formed the first part. So we have formed this area here. Okay, so we have drawn in that triangle there, and that's what it looks like. Right, we simply now have to step it off. It pays for this exercise to have two compasses. I've got a small one here. I'm going to set this at 1/12 of the circle. If I haven't mentioned that you must be accurate, I'll mention it again. You must be accurate. So I've double checked, and if I do that 3 times, I end up in exactly the right place. So that one I'm going to leave set permanently. Now somewhere on here is 1. So 1 here is out from the 0. So I just put an arc out here. Somewhere on that arc is 0.1. So A1, let's find A1. A1 is here. Being accurate, if I haven't mentioned you must be accurate, you must be accurate. Put that on point A and put a mark there. That is A1. We go from point 1, A1, put an arc here, and we find A2, and A2 is here. A2, so I've identified point A1, I've identified point A2, keeping the same compass, accurately place that in the center. Now this distance hasn't changed, so A3 will be somewhere on that line, on that arc. Let's go to A3, and there is A3. We can draw those in. This is a lot of fun. Right. Now, so we've gone all the way around here. We've done all that portion there. Excellent. So what do we know? Well, we know that these dimensions don't change, so I can put a line out here, and this will be B3. Somewhere out there is B3 on that arc. Now we also know that AB, and I can measure it at so many millimeters, or I can take it off the drawing here, and I can put an arc there. Now somewhere on this arc is point B. It's the same as that. That's a true length line. A and B is somewhere on this arc. So we know what B3 is. So let's go over here to B. B3 is out here. And so now I'm going to reverse this. I'm going to go from point 3 back, and that must be B. I can draw that in ink. And we've got B3. Let's do that in green. So we have now found that line. This triangle in here is this triangle in here, A3 and B3. We have an arc here, so we need to now find B4. B4 is here. Being very accurate, and we can go from here, cross that arc, and we have got number 4, and that is B4. Let's find point B5 again using the small compass that hasn't been changed. Somewhere on that arc is B5. Let's find B5. It's right in here. B5. And let's go to B6. Draw our arc. Get B6. Which is B6, which is in here. Again, being extremely accurate, I've got a big blob here, and that is B6. And we have B6. So we can identify what we've done. So we've done all of this now. So let's go to C. Oops, I've got a big blob here. My accuracy might. Oh, I can. Yeah. So somewhere on that arc is C, and we need to go to C6. Which is C6 is the same as B6. Put an arc there, and that will be C. Point C. And now we can go, which one's it? That one's green. C6. And the next number on our list will be 7. C7, somewhere's on there. That there, so it doesn't alter. C7 is the same as B5. And let's go to 8. C8 is the same as B4. And let's go to 9. So this is C9, which is the same as B3. And I can draw that in. Whew. Okay, so we've got that far. So you can go ahead and move on if you understand the process. I'm going to do it and talk through it all the way. So let's do CD. There's D up there somewhere, and D9 is the same as A3. So we're back to this one again, A3. Ooh, might only just fit on the paper. There's D, and we're back to purple, so that's D9, D9 here, and D9 is taken from here. We now have to go D10, D10 is the same as A2, and around we go to 11. D11 is the same as A1. Oops. And D12 or D0 is out there. D0 is the same as A0 or A12 or D12. Put that on there, and that's 12. So we've got all our points. Let's put that in. Righto. So that's almost all our pattern done. But what we have to do now is finish off with this corner here. So we have done all of that, 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 and we're just missing this corner here. Now that corner is exactly the same as this one, but we can work it out. So we know this length. We can take that, so we can take it off here, or we can take it off the drawing. It's exactly the same. Put that at point D, and that is our seam somewhere on that line. And we know that D12, and now this is a mistake that a lot of people make, this last line from 12 down is this true length here. It is a seam line down 0, 12, so it's at that seam line there, and it's this length. So if we take that down to here, so that's a seam line. So let's write those in to stop confusion. So seam length, and I'll write that on here too, seam length. So we can do that, and we can put them in here to 12, to point 12 or point 0. Now let's double check to see how clever we are, and that there will be a right angle. So in there we have a right angle. That triangle is exactly the same size as that triangle. Yahoo, we have done it correctly. So we've drawn in dark outlines, the square base. Now we have to do the circle. All you need to do now is cut this pattern out, fold it up, sellotape it together, and present it to your assessor. Thank you for watching, and keep your eye out for task 4 coming to a computer near you soon.